In this video, we're going to take a look at factoring quadratic expressions when the lead coefficient is not 1. Okay, so now down here in red, I have a for instance, for example, and I'm not really going to do that. Let's just pick something out here. Let's go with something we already are familiar with. So let's say we have something like 2x plus 3 is being multiplied by the quantity 4x minus 2. Ooh, let's not do that, because then we have to factor out a greatest common factor from 4 and 2. So let's make that a 3 as well. That way I don't have to do any extra work that we don't really want to do. All right, well, if I go ahead and distribute, not that godforsaken four-letter F word, which for the entertainment of those that might be watching that have had me in class, I shall say once and only once, and it does not count towards your pizza party, and that word is foil. Foil is something that you use to cover a pizza with when you reheat it. It is not something you do in math. Okay, so now that I've irritated about half of you, this guy's an idiot. He doesn't foil. No, remember, foil is a mnemonic device. It's not an actual operation in mathematics. It's not even a property. It's a way for you to remember what to do when you're multiplying two binomials. All you're doing is the distributive property. That's all. There's nothing magical about it. I probably have another video floating around in my collection of why is it the distributive property? How do we use the distributive property to do this? And so I walk you through, how we use it, and then I say, oh well, this is a quick way of doing it. And yay, everybody's happy because we learned a trick. It's not really a trick. All right, so I distribute. And so as I distribute, then I'm going to get 8x squared. And now I have a negative 6x and a positive 12x for a positive 6x. And then I'm going to have a negative 9. And that's what it is. Now you might think, okay, well this is fairly trivial. Why are you showing me this? There's a little something here that's kind of important. You notice this funny little thing in between? Yeah. This little thing allows us to do something that very few other signs allow us to do, and that is to go from one side to the other side. And nothing changes except for the way it looks. This is important because what we're going to do is we're actually going to start on that right side and we're going to move to the left side. And if we can take a look at what happens in all of the problems of this type, we might be able to find a quicker way of doing it. That's what we're doing here in the red. Take a look at this general type where you've got some number in front of x and some number in front of x, and they don't have to be the same, nor do they have to be 1. They could be, but they don't have to be. And now look what happens when you multiply these two binomials and you get, oh look, I get a mixed product there. I get a mixed product there, meaning they're coming from different factors. And wow, then something really messed up happens inside here. Yeah, they kind of swap places. It's like wife swap. Hey, we're going to switch wives for a little bit and see what happens. Ooh, it's usually bad. Okay, so something happened up here and we ended up with a little less than either of them. But that's fine. So what we're going to do is we have to find out, okay, well, what were the two original partners? And to do that, we have to somehow split them up into these 4 numbers. We're going to split that back end up so that we find two factors B and D. And we're going to split that front end up so we can find two factors A and C so that when we mix and match them in the center, we get what we want. I just so happen to have an example right here that we could try. Let's take a look at 7x squared. I love prime numbers. 7x squared minus 11x minus 6. And we got a lot of primes in here, so that's good. You say, I don't know why prime numbers are good. That's got to find this factor pair that works, right? Well, how many numbers multiply to 7? 1 and 7. That is all. That makes it really nice. However, if I want to split 6 up, I may have multiplied 1 and 6, or I may have multiplied 2 and 3. I don't know which. What we're going to do is we're going to find out which I did. Now, to further our cause, if you've never seen this before, and that's fine, I've got other videos on it, and I'm sure that there are multiple other teachers out there, a multitude of other teachers out there that teach this. I cannot be the only one. if you take a look at this back end sign here, the second sign, it tells you a couple things. Since you multiplied to get the 6, it tells you that the signs have to be different. So if we go up here to our example, notice we multiplied the -3 and the +3 together and we got a -9. Yeah, it tells us that the signs inside our factors have to be different. So I'm going to get something that looks like, and I'm going to just kind of put it over here to the side, I'm going to get something that looks like this. I know that already. There's got to be a negative, there's got to be positive. Can they flip-flop? Yeah, sure, that's fine. It doesn't really matter, it's multiplication. And so I'm going to get an x here, and I'm going to get an x here, and I already know half of what it's going to look like, simply because of that sign and the x squared out front. But it also tells us something different, or something additional. It tells us that when we combined our mixes, our 2x times -3 gave us -6x, but then our +3 times our +4x gave us a +12, and when we brought those two together, we actually subtracted. This tells us we're going to subtract. And so when we find these pairs and test these pairs, we're going to subtract their products. And we're going to try to make this middle number. But we don't care about the sign of the middle number because the sign really tells us which pair dominates. Or I should say the dominating pair has this sign. Which pair dominates has this sign? Dominates has this sign. Okay, so now all we have to do is find that dominating pair, and that pair must be negative. Well, because the only way to get 7 in front is to have 1 and 7, I already know it's going to be 1 and a 7 in front. That's wonderful. Oh, that makes it so easy. Okay, so now all I got to do is find this back end. So I'm going to start taking combinations of 1 and 7 with the other combinations and try to find something that subtracts to 11. That's what I'm hoping for. All right, let's take a look. Hey, if this doesn't work, that's fine. So we set this all up and then we say, oh, sorry, didn't work. So it's not factorable. Okay, that's fine. This doesn't take us very long. So here we go. I'm going to try combining 7 and 6 for 42. I'm going to combine 1 and 1 for 1. Now 42 minus 1 gives us 41. That's not 11. Okay, so that doesn't work. So let's try flipping the pairs. Let's try 7 and 1 and 6 and 1. Well, 7 times 1 is 7, 6 times 1 is 6. 7 minus 6 is 1, which is not 11. Okay, that didn't work. Well, since I have no other ways of pairing 1 and 6 and 1 and 7, I'm actually going to cancel out the 1 and the 6 because the only pair that I have to work with up front is 1 and 7. Now, if I had multiple pairs on each, I wouldn't have done that. I would have just said, hey, this one doesn't work with that, and try something different. All right, so moving on. Let's try 7 and 3. And so we're going to try matching up 7 and 3. Now, I'm not going to mark the other two, but 7 times 3 is 21. 2 times 1 is 2. 21 minus 2 is 19, and that is not 11. Okay. Well, let's try something different. Now, we tried 7 and 3 before, so let's try 7 and 2 here. We have 7 times 2 is 14. 1 and 3 is 3. 14 minus 3 is 11. We got it. We got it. We got it. Okay. So what do we got to do? We got to find out where the 7 is, and we got to match it up with the 2. So in order for the 7 to multiply the 2 actually has to be in the other factor, which puts the 3 in the other one. Now, I put my signs in here, but I said sometimes they might be in the wrong spot and you have to reverse them. And here it actually matters where the signs go because you're matching them with the pairs, not just the factors themselves. And so our pairing has to be negative. The dominant pair is 14. That must be negative. In this case, the 7 times the 2 must be negative. Since the 7 is positive, the 2 must be negative. And so our original signs actually worked. But you got to be careful. Sometimes they won't do that. So we found out that if we factor this one, we actually factor it out to x minus 2 and 7x plus 3. Now, you'll notice that I didn't do anything beforehand. I didn't take out a greatest common factor, that sort of thing, or put it in order. This was an easy one. There were no greatest common factors. You always start out, is it in standard form? Is it in order of decreasing powers on x? And once that's complete, you just check for, does it have a greatest common factor? If it does, factor that out. It can only help you. It'll give you smaller numbers at the very least. Only then do you go back and say, what do I got to do now? For this one, we just had to mess with it a little bit. So that's the idea. Don't be afraid to look for new and more efficient ways of doing it. It's not that bad. But you have to understand a little about something about what's going on. And so if we break it down a little bit and we just take it apart a little bit at a time, see what's going on underneath, we find out, hey, we don't have to go through all that stuff about grouping and AC method and working with huge numbers. We can just do this. Incidentally, a student showed me how to do this. It was a lot of fun. I'll come back with another example.